Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and we will try to solve it together. So if you talk of concept wise, today's challenge is not so difficult. It is a medium problem if you talk concept wise. Okay, but it requires a lot of prerequisite. Okay, so I will try to make the video in such a way that there is no prerequisite. That is, I will try to explain everything from scratch. So it consists of concepts like div mod and mod inverse and binary exponentiation, okay, and Fermat's little theorem, okay, many thing it consists of. Okay, I will try to tell you everything from scratch. And yeah, these all mathematics concept, it just and how do you find summation of AB in a very short format. So let us try to understand the concept first, okay, and then we will go on to explaining each and every of this mathematical concept and also how to apply that in code and how your why do we need to at all apply those and how we will make the code run, okay, using these concepts. Okay, so first of all, let's try to understand the problem statement. Okay, so count the number of trapezoids 1. You are given a 2D integer array points where points of I is xi comma yi represents the coordinates of the ith point on the Cartesian plane. Okay, and the horizontal trapezoid is a convex quadrilateral with at least one pair of horizontal sides parallel to the x-axis. Two lines are parallel only if they have the same slope. And return the number of unique horizontal trapezoids that can be formed by any 4 distinct points from the points. Since the answer may be very large, you need to return modulo of 1 plus 7. So what it is told in the question is count the total number of horizontal trapezoid forms. Okay, so horizontal trapezoid. So if you don't know what is a trapezoid, it is a quadrilateral with one pair of sides parallel. Mathematically speaking, at least one pair of sides parallel. Okay, so let's say you have these 4 points where, and it is told a horizontal trapezoid, right? So they must be parallel to the x-axis. So if this is the x-axis and y-axis, these lines must be parallel to the x-axis. So this is a horizontal trapezoid. Okay, even any rectangle or any square or this kind of parallelogram where these two sides are parallel to the x-axis, they are all coming under the category of horizontal trapezoid. Okay, so let's see uh, how do we do that and how exactly will you count it. If you try to see this problem, okay, this thing, there are 5 points, right? 1 comma 0, 2 comma 0, 3 comma 0 and 2 comma 2 and 3 comma 3, and you can see that you can form 3 of the trapezoids. So at any time, see, in order to make two sides parallel, you must make sure that you are selecting two points, right? These 2 points you are selecting in one line and the other 2 points also you selected in one line. So you must ensure that 2 points you select in one line. So I am telling you a test case and you will try to tell me that how many horizontal trapezoids are there. So let's say these two are the lines which are parallel to the x-axis. Okay, this is the line. Okay, and let's say I have these two again and I have another 2 points. So if this is the x and y axis, can you tell me how many trapezoids can be formed from here? So you see, this is a possible line where 2 dots are there, right? 2 points are there. This is a possible line where 3 points are there. Okay, and this is also a possible line where 2 points are there. So at least 2 points you need to select, at least not exactly 2 points you need to select. So your trapezoids can be some, first can be something like this 1, another one can be something like this 2, another one can be something like this whole thing 3. So you got 3 trapezoids. Similarly, between this line and this line also there will be 3 more trapezoids. Now between this line and this line also there is one trapezoid, you see. So 3 plus 3 plus 1, 7 will be your answer. Okay, so I hope now at least you understand how exactly the trapezoids is counted. And if you try to see what exactly we are doing is selecting 2 points. What if we increase, what if I increase the number of points? How will you solve it? So you will, in this case, you will see that instead of counting each and every one, you will see that how many points are there and how many ways of selecting 2 points. So there are 3 points in this line, right? How many ways you can select 2 of them? 3C2, right? I hope you this much at least you know from your higher school. Okay, so and this will be 4C2 and again this will be 2C2. So if you try to form a connection between this line and this line, okay, so let me just tell that see, nc2 you can easily calculate using n into n minus 1 by 2. I hope this you already know. Okay, you can prove it easily using the nc2 ncr formula. You can just go ahead and check that out. So nc2 is given by this. So I do understand that there are this many pairs of selection. Okay, so let's say this will be a, this will be b, this will be c, right? So can you tell me how many total ways are there? If you are trying to select these points, so what I am trying to say is that if you try to select these two lines, if you try to select, there will be A into B. Now if you try to select these two lines, there will be B into C, number of pairs, number of trapezoids. And if you try to select this A and C, there will be A into C, AB plus BC plus AC. So this was also the case when we counted the number of trapezoids. So for when the answer came out to be 7. So I will just quickly show you that when we have this case analyzing, right, here there was 2 points. So 2C2 which was 1, right, 2C2 is 1, and we have 3 points, 3C2 it is 3, and for this we have 2 points again, 2C2 1. If you try to check between these two, there were 3 trapezoids, so 1 into 3, so 1 into 3 plus you get 3 into 1, another 3 points plus you get 1 into 1, so total of 7 points you get. That's how you calculate, right? Now you must also notice very easily that all the points that lie on the same line belong to the C. This has some coordinates x1, y1, this has some coordinates x2, y2, this has some coordinate x3, y3. But can you say what is the similarity among these coordinates? I guess this is at least very simply. This you can easily tell that y1 is equals to y2 equals to y3. That is the y coordinates of all of them are same. So one thing which you can easily tell that group by, when you are iterating through the points, group by y coordinates. Okay. In short, what you need to do exactly is count the number of y coordinates. Okay, so group by the count of y coordinate. Okay, y coordinate. So how exactly I am trying to do this is that I can try to store the count frequency in a map. Okay, so let's say this whole thing has the y coordinate of y1, this whole thing has the y coordinate of y2, this whole thing has the y coordinate of y3. So my map, my frequency map will store something like y1 is 3 points having, y2 is having 4 points, y3 is having 2 points. See, once you get this, you can transform everything whichever you have into nc2, 3c2, 4c2, 2c2, everything you can just transform it, and then you try to multiply them each. If this is abc, you just try to multiply them. Okay, and now I will tell that what if you group by the y coordinates and you see that for the first y coordinates there is, let's say, a1 number of thing, for the second y coordinate there are a2 number of points. See, this is frequency, so this is key comma value pair, and value is nothing but the frequency of the y coordinates. I hope this much is very much clear. Okay, and what if there are n of them? What I want to say is, what if there are n of them? For 3 of them, I easily saw that AB plus BC plus CA, or A1, A2 plus A2, A3 plus A1, A3. But what if there are n of them? You need to multiply with each of them. See, between this y coordinate and this coordinate can be there a point. So A1, A2 I will write. Between this coordinate and this coordinate there will be a point. So A1, A3 I will write. Between this coordinate and so on, all the way till A1, AN. Similarly, between A2, A3 will be, there will be a point. Again between, let's say, A2, A4 and so on till A2, AN. And again we will keep doing this a2 a4 and so on till a3 an, right? So this will be your answer. And when n equals to 3, we easily saw that our required answer was a1 a2 plus a2 a3 plus a3 a1. Now if you see, if you use a double for loop in order to traverse, now the number of what is the range of the y coordinates told in this problem. You see the range of y coordinates is 1e8, okay, so there can be a lot of points over here, okay, and even this points dot length is 1e5, so there can be 1e5 different number of y coordinates. So in that way you cannot just use a double for loop to calculate this, right? You have to use some mathematics. So I hope you, if you try to remember this kind of problem, what is the value of a plus b plus c whole square? If you see, you get something like a square plus b square plus c square plus 2 into ab plus bc plus ca. See, this term you get it from this, okay, from this expansion of a plus b plus c whole square. And if you see, this is calculatable in linear time, you just add the values. This is also calculatable in linear time, so this should also be calculatable in linear time if I just subtract these two and divide the whole by 2. What I am trying to say is that can't I write this simply as ab plus bc plus ca to be something like a plus b plus c whole square minus a square plus b square plus c square by 2 whole divided by 2, okay. So now how exactly will this work? You see, in general you can also write for summation of ai whole square, you can write summation ai square plus 2 into summation ai aj, summation uh, ai aj, okay. So that is how it happens, and for this value you can easily use, see this has two summations, so it requires two for loops, right? But these has these all of them, this term and this term has a single summation, so you can solve it using single for loop, right? So basically what you need to do in order to find this whole, see what you are trying to find, this whole a1 a2 a1 a3 a1 an. So in order to find this, what you can simply do is add all of them and calculate the sum, okay, square it, minus you calculate the sum of squares. So sum of squares means a1 square plus a2 square plus a3 square, so you calculate that sum of squares. This in O of n, both of these you can calculate easily in O of n, you just subtract them and whole divide that by 2, okay. You just subtract this and whole divide that by 2. Now there is a very interesting thing over here. See, so the final answer which came out was something like sum of all of them I derived from this formula, right? This is nothing but sum of all of them whole square minus sum of squares, let's say, okay, the whole divided by 2. So that's how you will get this term, this particular term, and that is going to be your answer, okay, that is simply going to be your answer. But you need to calculate it modulo, right? Modulo md. So there will be a very interesting case over here, that is that what is the value of a modulo a plus b whole mod? You know that it is very simple. I can write it in this way, a modulo mod plus b modulo mod whole modulo, okay. This you can write easily. But you see there is a subtraction over here and there is also a division over here, so you cannot do this subtraction and division simply, you cannot apply a mod. For subtraction what you generally do is a minus, if you try to calculate a minus b whole modulo, then it is actually given by a modulo mod minus b modulo mod plus mod whole mod, okay. This is why it is given. And why exactly do we do this mod? The reason is that this too can give you a negative number. So let's say if you are trying to do some modulo 6, okay, and let's say a is 2, b is 4, and you get minus 2. So what is minus 2 modulo 4 mod? Okay, it doesn't make sense. But if you talk of in mathematics, -2 just wraps around. When you do a modulo, it just wraps around itself. So what do I mean is that see, 1 modulo 6 would have been 1, right? So similarly, if you try to do -2 modulo 6, it will be actually +4. So how do you get this +4? You just add this 6, whichever mod you are doing, you just add to that and you perform a whole mod. So you get nothing to be 4. So that's why a minus b mod is calculated in that way. And if you talk of a divided by b mod, there is a whole different story about that. We will learn it in this video only. If you try to do this, so basically what you have to do in this is that a modulo mod multiplied by this b inverse modulo, okay, whole modulo, and b inverse, you might be thinking b inverse mod, how to calculate that can be given in using the Fermat's little theorem, which says that b inverse modulo is nothing but b to the power modulo minus 2 whole modulo, okay. So these two are equivalent to each other, so this value you can replace it by this, and this is a very large number. If you see, modulo is 1e9 plus 7, so modulo minus 2 will be a very large number. So you can use the binary exponentiation to calculate that. That is, you will not just physically multiply b that many number of times, because it will give you a time complexity, time limit exceeded error. You will instead use a binary exponentiation. That also you need to write it from your own. There is no function in C++ that will give you this, so that we will also see. So so first of all, let's try to do what we did, what we discussed initially. Let's try to start the coding and group by y coordinates at first, okay. So what we will do, we will use an unordered map at first, okay. So let's say n is the number of points which we have right now, and unordered map is nothing but integer comma integer, okay. So I will use a long multiple number of times here. So let me just define hash define ll long, and so I will try to use long only, and I have this map, frequency map, which will give me what it will give me, y coordinates comma the value comma the frequency, okay. So how exactly we will do that? We will traverse through these points and just have it. So I equals to this, and what we do is very simple, points of I of 1 plus plus. So we store the frequency of all the y coordinates right now, okay. And yeah, that will be it. And what else, I need to have a result with me, okay. And let's see, I will calculate the result later. First, after having grouping by the y coordinate, I have this a1, a2, a3 values. So we need to convert that to first this. I directly do not have this a values, right. What I need to do is now also to convert nc2, right, because see, this was the frequencies. So there are y1 is having 3, y2 is having 4, y3 is having 2, but what are actual a, b, c? They are nothing but 3c2, 4c2 and so on till nc2, right. So we need to just take care of that. So let us iterate through the map in the key comma value pair, okay. Let us simply iterate through the map, and this value we will try to first find the count, okay. So ll count will be nothing but v into v minus 1 by 2, and I will try to perform something like count equal to count modulo mod, okay. So let's have a modulo over here. It will be nothing but 1e9 plus 7, right. So what is this? What is this count? It is nothing but vc2. We choose to out of all the pairs, you can choose any two pairs, and how many ways of choosing this is vc2, which is nothing but v into v minus 1 by 2. That is the count. And what do I need to do? I need to calculate the sum and sum of squares. If you remember, I need to calculate the sum and sum of square. Okay, so that's how. And how do I calculate the sum? It is very simple. You just do this addition and it just works fine. And how do you calculate the sum of squares? That is also quite okay. So sum of squares will be nothing but sum of square plus this count into count, right? So you just square them and sum each of them, right? But this will give you a long and you must convert this to modulo first, and the whole thing will be whole modulo. Okay, so you do get the sum and sum of squares ready with you, right? And you are now ready to apply this formula, whatever this is, sum square minus sum of squares divided by 2. Okay, so you have your result with you, which will be nothing but sum square, sum into sum, minus sum of square whole divided by 2. Okay, so minus sum of square whole divided by 2. So this is the thing which I ideally want to do. Okay, but since I need to apply a mod, there will come a lot of things. So first of all, this will be long. I need to typecast it to that and perform a whole modulo. Okay, this thing is there, and this sum of square is also there, and I do a plus modulo and then again a whole modulo. Okay, so just make sure that the brackets are being given correctly. So yeah, there are three starting brackets as well as 3 closing brackets. So we have this result with us ready. But see, divided by 2, you cannot just divide by 2 and keep modulo, because you are doing a lot of different stuffs here, right? You are dividing, if you are calculating the remainder mod, you are doing a lot of different things. So I will write a function div mod. So basically what does div mod do? So this div mod takes a, b and mod. Okay, what it returns will be a by b whole mod. This thing which you cannot calculate directly, it will just calculate it for you. So I will try to write that whole thing, and basically, so what I want to write here is that this whole result, this whole answer, this whole numerator divided by 2. See, I need to divide the whole thing by 2, right? And I need to do a modulo mod. That's how the result will be, and I can simply return the result. I can typecast it to integer since it is told, and just for safety purpose I will apply another mod. So see, this is here. So now, as I told you, how exactly will you calculate this div mod? So long div mod will be your answer. So long a is there, b is there, and you have this mod with you also. Okay, so what exactly you calculated, need to calculate here is this. Okay, and if you know how to see, I will tell you from the basics. You know that how to calculate a into b whole mod. You just apply mod separately. A mod multiplied by b mod whole mod. Okay, perform the whole mod, and this is how you calculate. So a by b, what you can do, a by b whole mod, you can write it in this manner. Okay, a multiplied by b inverse mod. Okay, and you can write it simply a mod multiplied by b inverse modulo mod. Okay, so again with this you can calculate. So first of all, first write this. Okay, you know that this will return, div mod will return this, so first try to write this. So what does it do? It just returns a modulo mod and what it is, multiplied by b inverse modulo 1. So see, b inverse modulo you cannot calculate it so easily, so I will have another function for that. Okay, so mod inverse, I will call that mod inverse function. It will just take this b and this mod, and we'll calculate the b inverse mod. Okay, and whole modulo, you just multiply both of this and perform a whole modulo. This will be your return of div mod. I hope you do get it, how div mod is calculated. And what about this mod inverse? Write a separate function for that. Mod inverse. Okay, so let's say you have x and you want to calculate x inverse of mod, right? So how do you do that? So here comes the Fermat's little theorem. You can just Google that out. What does it tell you? That if you want to calculate the modular inverse of anything, that is equivalent to calculating b modulo minus 2 whole mod. Okay, so basically it tells you this, b inverse congruent b modulo minus 2 whole mod. Okay, what does this congruent and all means? I have already explained you in some of my previous videos in modular arithmetic, but this is a theorem which you can just know that it exists. So that's how you calculate modular inverse. So this is a very large number. If you see mod minus 2, so you calculate exponentiations. Okay, so I will write another function, binary exponentiation bin pow, which will take a and b, and not a and b, it will take a and e, where and it will mod, and it will calculate a power e whole mod, right? And see, you need a power e here, where a is b and e is mod minus 2. And what you cannot do over here is multiply a e times. You cannot do that. If you do that, you need to use something else. Okay, so if you do that, there will be a TLE, because e here in this case is mod minus 2, which is of the order of 1e9. So your time complexity will be O of 1e9, which is not possible. Okay, over here. Okay, so mod inverse will return binary exponentiation of x mod minus 2 mod. Okay, I hope you do get this right. Mod, so I am calculating x to the power mod minus 2, nothing but this. Okay, so now x to the power mod minus 2, that's how. So I will write a separate bin pow function which will just take a and which will just take an e exponent, and it will calculate, it will also take mod, and it is going to calculate what is the value of a to the power e, and it will try to calculate in a fast manner. Okay, because yeah, we don't have time for that. So how you calculate it very fast without using a loop? So you cannot multiply a e times. So let's try to analyze something. Let's say you want to calculate something like 6 to the power 11. Okay, in a fast manner again. So 6 to the power 12, let's say. Here a is 6, your exponent is 12. Can you write the binary form of this exponent? Okay, so if you try to convert this 12 into binary, what does it mean? This is 8. Okay, this is 10, and this will be 12, right? If I am not wrong, 8 plus 4, this is 12. So instead of 12, let us take 11 only, right? Why I am taking 11? It will be understandable to you, so more clearly. Okay, 6 to the power 11, where e is 11, and 1011 is the, so this in binary means 1011. Okay, so I hope this is very clear to you. At least I don't need to show you how to calculate decimal to binary. That is very basic. And yeah, so you have this in front of you. Now what does this binary means to you? Wow, what exactly does this mean to you? See, this is 2 to the power 0, right? How can you write it in this way, that 1 into 2 to the power 0 plus 1 into 2 to the power 1. Okay, and plus 0 you have 0 for this. So 0 into 2 to the power 2 is the same thing, and 1 into 2 to the power 3. Okay. Now 2 to the power 3, you know it's 8. This is nothing but 2. This is nothing but 1. 8 plus 2 plus 1 is gives you what? 11. Okay. That is how you see. So what interpretation can you make for this? What interpretation can you make for this if you want an exponent of 11? So you can keep 6 and multiply, instead of 2 you can multiply 6 every time, right? So you can iterate through the bits of this 11 and keep multiplying some result. Okay, so let's say initially you have result equals to 1. Okay, and you have this number with you. Okay, so this will give you so you keep an a value which you want to multiply. Let's say this is our multiplier. Okay, and it is initially 1, and here it will give you 6. So 1 into 6 basically. Okay, and here it will give you 6 square, here it will give you 6 power 4, here it will give you 6 power 8. Okay, this is what? 6 power 8, 6 power 2, 6 power 4. So now in whenever you get a 1, you multiply it. Whenever you get a 0, you don't multiply it. So if you multiply 6 power 8 into 6 power 2 into 6 power 1, you get a 6 power 11, right? So that is how binary exponentiation works. If you want to calculate 6 comma 11, okay, what you need to do is iterate through the bits of 11 and right shift every time. So you can do something like see, this is a comma exponentiation, right? So while exponent is greater than 0, you see what is the last bit of e. How you can check the last bit? You can just do e and with 1. Okay, if e and with 1 is true, then you can choose to add multiply your result into equals to a. Okay, and every time, otherwise every time what you can do is a equal to a into a. What is this? I am doing a equal to a into a. It means that from 6 it will go to 6 square, then it will go to 6 power 4, then it will go to 6 power 8. Every time you see a is becoming a into a. So that is what, irrespective of anything you do it, and at the end you also right shift your e by one unit. Okay, you right shift your e to 1 unit, and at the same end you can simply return your r, and you can perform the modulo over here, and that is what. Okay, so I hope this binary exponentiation is very clear. It is still, if it is still not clear, you can just go through and search for it in the web. I hope this is clear only. How exactly this speeds up the calculation. Earlier what I was trying to do is multiply 6 11 times. 6 I am trying to multiply it 11 times, right? So instead of 11 times, what is the number of times that I am using this loop right now? It is only 3 times. Okay, so when it is the log number of times basically. Okay, so complexity is log of n, log of e exponent. Okay, so no matter how much large the exponent is, you can use this binary exponentiation to calculate that. And yeah, we will just do that over here. So you have your result with you initially, which is 1. For safety, first let's me do something like a equal to a modulo mod, and while exponent is greater than 0, you try to right shift every exponent. Okay, right shift the exponent by 1, and if the last bit, if you see this exponent and 1, if it is true, you add your a into your answer. Okay, so r equal to r into a. So if you are trying to talk of mod, how you can do it? It's very simple. You can just do this ll. See, these all are ll, so no need to typecast it. You can just directly perform this modulo, and every time what you can also do is a equal to a into a. So perform a mod over here also. So I guess you have it with you, and at the end you can simply return r, the result with you. Okay, so yeah, this binary exponentiation will calculate this mod inverse by Fermat Little theorem. This mod inverse will give you this div mod. Now this div mod will help you calculate this result, and you finally get the result with you. Okay, so that is all the difficult part of in this problem. I guess this logic was very simple and easy to understand. Only this mathematics portion you need to have a lot of background for this. I hope I was able to explain you from scratch everything. Now I will try to run this code and try to debug if any errors are there. We will see. So mod inverse, there is something like mod I have defined here, so I need to write that only. Let me see what more debugging we need to do. You see, we got the accepted thing for 2 of these test cases. If we try to submit it and check if it works at all. Yeah, you see, we did get accepted for all cases, and we also have a decent runtime complexity. Okay, uh, if you try to analyze the complexity, it is a simple O of n solution. Okay, because you are storing everything in the map, you are going through these points once only, and then you are just iterating through the values of the map. That is also you are doing once, and this result is all mathematics. It does not use any loop or anything. There is a loop over here, but that is log of e order. So yeah, that is very simple, and I hope this problem was finally very clear to you from the very basics. So I hope you must not have any doubt in this. Even if you have a doubt, don't worry to ask in the comment section. And yeah, this much detailed video, if you liked it, if you learned something new, then definitely do mention that in the comments. It gives me motivation to keep making such further videos. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.